All right, for the last lesson in Unit 12, we're talking symmetry. Now, there's a few different types of symmetry you can see in the learning targets. Yeah, it's really about all you need to know. There's different types of symmetry, and I'm going to show you both of those. So a figure has symmetry if there is an isometry, and there's that word again, that maps the figure onto itself. Isometry again means congruent shape, and so no change in the size or the shape, which makes sense. If you have symmetry, one side is equal to the other. All right, so two isometries that we have seen already are reflections and rotations. I have another one that we've done, but that one does not really play into symmetry at all. But these two do. All right. These give us two types of symmetry: reflectional symmetry and, you probably can guess it, rotational symmetry. So we're going to focus on the first one first, reflectional symmetry. This is the symmetry most people are familiar with. This is where one half of the figure is a mirror image of its other half. If you fold the figure along the line of symmetry, the halves match up exactly. Because of this characteristic, reflectional symmetry is also called line symmetry. So those mean the same thing: reflectional symmetry, line symmetry, same thing. A figure with reflectional symmetry may have one or more lines of symmetry. All right, we're going to draw all the lines of symmetry for each figure. So the regular pentagon, this one should be pretty easy to see, that first one there. We change colors and give you another one. Not the greatest straight line, but you get what I'm trying to do here. Another one. And another one. And let's see, another color. Let's go black. Another one. 5 lines of symmetry. And there's 5 points. Is that always the case? Let's see what happens on the next one, the rectangle. Pretty easy to see this one here. And then the other one is here. Could I go from corner to corner? No, because what would happen is the corners would not line up. The other 2 corners would not line up if I flip it over that line. This one only has 2 lines of symmetry. So the conjecture I had from the number 1 was 5 vertices, 5 lines of symmetry. Not true. Okay, so that's not always true. It just happened to be that way in number 1. Okay. Now, rotational symmetry. A figure that has rotational symmetry is its own image for some rotation of 180 degrees or less. Basically, as you turn the figure a certain number of degrees, it matches up with the original figure. Find the angle of rotation for each figure. So this is almost exactly what we did with rotations. If I take this point here, how many degrees does it have to go to land there? Well, 360 divided by 3, because there's 3 different points there. The angle would be 120 degrees. 360 divided by 3 is 120. A regular hexagon. Now, the nice thing is I don't really care about clockwise or counterclockwise. If it has rotational symmetry, it just lands. When it stops, it's the same shape. So if I go clockwise or counterclockwise 1 step, it doesn't matter. How far is that step? This one, it's 60 degrees. The parallelogram is a little trickier. Let's say we start here. If I go 1 step, I have a picture that is not quite the same. It's not even close, actually. I have a parallelogram that looks kind of like this, right? Which is not what I want. Okay, but if I go 1 step further, that one would match exactly with what I have right now. So I go, how far is that? To go to the complete opposite side, it's 180 degrees. All right, so 180-degree symmetry for number 3. Let's go to the back. In the last example, the parallelogram, the angle of rotation was 180 degrees. A figure with rotational symmetry with an angle of rotation of exactly 180 degrees is said to have point symmetry. Okay, that symmetry is a specific type of rotational symmetry. So point symmetry is a type of rotational symmetry, but it is exactly 180 degrees. Okay, now for the last part here, we are going to do a couple things. One, what type of symmetry it has. It could be both. If it has reflectional symmetry, draw the lines. If it has rotational symmetry, give the angle of rotation. All right, so this one has reflectional. I'm just going to abbreviate it that way. It also has rotational, but specifically point. Now, I don't really need to write it. If I write point, that tells me the information I need. It means the rotational symmetry is of 180 degrees, right? So if I started here, I wouldn't get to the same picture until I landed here, okay? Some people think, well, what about 90 degrees? That's not gonna work either, because if I go 90 degrees, this crossbar is gonna be going the opposite way. It's gonna be going that way. Don't want that. It's not the same picture then. So it is point symmetry, which is 180 degrees. I did say it has reflectional, so let's draw the lines of reflection right down the middle this way and right down the middle this way. Okay. Second one has reflectional, and that there's one here and here, but actually you do have one here and here. Okay. So there's actually 4 lines of reflection here. It does have rotational, and it would be 90 degrees, because I could do this. I could turn this thing 4 times. It would land and be the same shape 4 different times. So 360 divided by 4, 90 degrees. The third one has no symmetry at all. And the fourth one only has rotational symmetry. There's no line that I could draw down the middle of this thing. Okay. So a lot of people think maybe this way, and that's not going to quite match up. So this point isn't, it's not quite the same. So it's not got reflectional symmetry. It's got rotational symmetry, but it's only 180 degrees. Because if I go 90 degrees, it's going to be up and down. So I got to go keep going. It's going to be point symmetry again. Okay, so that's symmetry, pretty basic, and that's it for the unit, and we are all finished.